Hi, Assalamualaikum. My name is Nur Aiman Afzan bin Azhar from class JCS 1103F. Today, me and my group's members, Farsha Sazmin and Sarah Aisha are going to present our presentation.
The topic we will be discussing is how to use differentiation to assess the rate of the melted ice cream from an ice cream cone. Before we get started, let me clarify what calculus is and why we choose to talk about it in our presentation. Calculus is a study that many people would dismiss as being pointless. Nonetheless, if we look at our daily life, we can find that calculus is a variety of tasks and actions. Calculus is extremely important due to its wide range of applications. Calculus isn't used for mathematicians or analysts. It is employed in physics, chemistry, biology, engineering, and a variety of other fields. Differentiation is a concept in calculus that is frequently used.
One of the topics in calculus regularly implemented in real-life situation is differentiation. And in that case, what does differentiation imply? It refers to the act of separating or distinguishing two or more things or even individuals. The derivative is the heart of calculus. The derivative is the rate of a change of a function with respect to one of its variables at any given time. Finding the slope of the tangent line to the function point is the same thing.
In this video, we will be solving a related rates problem. Finding a rate at which a quantity changes by comparing it to other quantities whose rates of change are known is referred to as a related rates problem. Usually, the rate of change is measured in terms of time. We can utilize implicit differentiation to relate the rate of change dx over dt to the rate dy over dt. An example of a related rates problem is assessing the rate of a melted ice cream from an ice cream cone, which is the topic we'll be discussing today.
Let's say that the ice cream is melting from the ice cream cone and moving at the rate of 0.03 feet per second. And then, the height of the ice cream cone is around 2 feet. And the radius at the top of the cone is 1 feet. So, the question is, at what rate the height of the ice cream inside the cone changing when the height of the water is around 1 over 2 feet cubes? We know that dV over dt equal to negative 0.03 feet per second. We need to determine dH over dt equal to what when h equal to 1 over 2 feet. By using chain rule, dH over dt equal to dH over dV times dV over dt. To find dH over dV, we know that V is equal to 1 over 3 pi r square h. From the figure, we have similar triangles. Hence, the ratio of the side in the triangle is the same. So, r over h equal to 1 over 2. So, r equal to h over 2.
Substitute the value of r into the volume. Then, simplify the equation. Differentiate the equation to obtain dH over dV. Since we have obtained dH over dV, and we know dV over dt equals to negative 0.03 feet per second, apply the values to the chain rule equation we did earlier, which is dH over dt equals to dH over dV multiplies dV over dt. So, it will be 4 over pi h squared multiplied negative 0.03.
We want to find the dH over dt when h equals to 1 over 2 feet. Therefore, when h equals 1 over 2, then dH over dt equals to negative 3 over 25 over pi 1 over 2 square. Then we can finally know that the height of the ice cream is melting at the rate of negative 0.153 feet per second. We constantly think calculus is unnecessary and a difficult subject to understand, but what we don't realize is calculus in actuality is frequently used in our daily lives. For example, the method we used for the melted ice cream, which was finding the rate of change, can be implemented in various kinds of situations.
For example, as we are aware that Malaysia is currently suffering from COVID-19, the method used can be used to evaluate the rate of growth of the virus. With this, our biologists will be able to predict the time it takes for the virus to spread in a particular area or city and take measures to prevent further complications.